So you can think of this a couple different ways, but this is an odd root, so it's okay to get a negative here. And 3 over 3 is 1, so this is just negative 5 to the first, or negative 5. This is an even root, so you will not get a negative here. So if you did that, well, you can think of this a couple different ways. Square root of 20 positive 25, which is positive 5 there. This one is an even root, so you know it's going to be positive. So it's just the square root of the numerator divided by the square root of the denominator. And so that would be square root of 1 is 1, square root of 7 square root of 49 is 7. This one is an odd root of even, so it's definitely not necessarily going to be positive. It could be negative or positive. I would just use the fraction 6 over 3, so a squared. Actually, it will be positive because it's squared. This will be positive, so technically, the best answer for this one is the absolute value of a. That's the definition of that. Because that's an even root here, and an even root there, it's going to be positive. Multiply if possible. Okay, so let's try to multiply here. So inside of here, you get cube root of negative 7 to the third power. And so that would be negative 7 to the 3 over 3. Remember, we can have an odd root and get a negative, so we will get a negative there, negative 7. This one, if we multiply, let's see what we get. So we get 5 on the outside. We get cube root of a whole bunch here. We get 2, we get 3 to the 5th, y to the 3rd. And some of that's going to simplify here. So it looks like the 3 is going to come out. 3 to the 3rd, that's a 3 there. So we're looking for 3 of something, so the 3 is going to come out. So 5 times 3. A y is going to come out as well. No y's left over, no 3's left over, but there is a 2 left over, so there'd be a cube root of 2 left over. And so that ends up being 15y times the cube root of 2. Wait a second. Sorry, this is 5 right there. This cube root of 5. So there is a 3 left over in there. There's a 3 squared. Or you could write that as 2 times 9, which is 18. Sorry about that. I didn't realize that was a 5. I misread my own writing. There was 5 in there because this one nicely simplified, but there's 2 left over there inside. Sorry about that. Number 8. So it's just, I would, since it's already one big fraction in there, let's just simplify that fraction. You have 7 on top, 3 in the bottom. Some of those are going to cancel. So when you do, the property there is the 7 minus 3 power. So it'd be 2 to the 4th. And this is square rooted, so it's going to be 2 to the 4 over 2 power, which is 2 squared, which is 4. Can't have a denominator like that. So what I like to do is think about the end game here. What's the what would the denominator ideally be? I would love it to be the third root of 5 to the third power. Right now it's 5 to the first power. How many do we need? We're missing 2 of them, so cube root of 5 squared, cube root of 5 squared, cube root of 5 squared. So we have cube root of 5 squared, or 25 up top, divided by 5. This one is a binomial, so you have to multiply by the conjugate. The conjugate of 3 plus square root of 7 is 3 minus square root of 7. So I'm going to wait on distributing up top, but I want to simplify the denominator first because maybe it'll cancel with the 2. So just do first and last. So 9 minus square root of 7 times square root of 7 is 7. So we get a denominator of 2, and that's the reason why I did not cancel. I was hoping it might, kind of that 2's might cancel here. And they do. So we just end up with 3 minus square root of 7. I guess technically that's 2 times 3 minus square root of 7. Okay, you're hoping, and you can definitely use the factor command in your calculator if you need to for these. So you can bring up your calculator and go, okay, let's do, so square root of 45, so square root 45 No, not square root of 45. I need, sorry, the factor command, menu 3.2, or menu 2.3, that's what it is. Menu 2, menu 2, 3. We're going to factor 45, and menu 2, 3, we're going to factor 20. Okay, so 45 is 3 squared times 5. So this is square root of 3 squared times 5 minus square root of 2 squared times 5. That's nice. Okay, so square root of 3 squared is 3, so we get 3 root 5. Square root of 2 squared of 4 is 2, so minus 2 root 5. Those go together nicely. 3 root 5 minus 2 root 5 is a total of 1 root 5, or just root 5. Let's prime factorize a 54 as well. So 54, and it's prime factorized 16. Okay, so we have cube root of 54 is 3 to the third times 2, and then we still have the x to the third inside of there, plus this is cube root of 2 to the fourth. I'm going to write it this way, 2 to the third times 2 to the first, just to make it more clear that the 3 of those are going to come out, but one of them is going to be left over inside. So this one's going to simplify. This is going to be 3 on the outside. This one's going to simplify. This is going to be x on the outside. The 2 is left over inside there, so cube root of 2 plus 2 is going to simplify, so it's going to come out. X is going to simplify, that's going to come out. And we're left over with a 2 inside there, so cube root of 2. I have 2x cube root of 2 plus, 3x cube root of 2 plus 2x cube root of 2. That's a total of 5x cube root of 2. Okay, this one is going to be 3 times 4 is 12. Outside would be plus 3 root 2. Inside is plus 4 root 2. That's plus 5 root 2. I'm sorry. 3 root 2 plus 4 root 2 is 7 root 2. 7 root 2. And last times last is plus square root of 4, which is 2. So I get 14 plus 7 root 2. Simplify each expression. So if you don't know this, like you can always just write the prime factorization. So instead of 25 to the 3 halves, we're going to write 5 squared. Now we do power of power, that's 3 halves. So it's going to be 6 halves, which is 3. So 5 to the third, which is 125. This one uses prime factorization. We just did that. So this would be 2 to the fourth is the same thing as 16, but that's being put to the 1 half. 2 squared is 4, so that's the prime factorization of 4 to the 1 half. So 4 times 1 half is 2, so this is 2 squared times 2 to the first, because half of 2 is 1, which is 2 to the third, which is 8. One in simplest form, so this is being distributed to both exponents there. So this would be negative 2 to the first, essentially, times y to the fraction of power 9 9/3, which is 3. So we get negative 2y to the third. I think there we do. And this one, okay, so that's going to both exponents there. So this would be x to the negative 4/5 over x to the positive 1/5. And so remember, we're doing that's subtraction. So x to the negative 4/5 minus 1/5 is really x to the negative 1 or negative 5/5, which is 1 over x. I think is your final answer there. Because when you divide with exponents, you really subtract the exponents. Solve each equation. I want to get it all alone first. Let's get that 5 on the other side here. So that cancels over here. So we get 3x plus 1 to the 1/4 equals 2. Now we're going to put both sides to a certain power, and I always do the reciprocal power of that fraction. So 1/4 reciprocal is 4, so I'm going to put both sides to the 4th power. So this is just 3x plus 1, that's pretty nice, equals 2 to the 4th we did a minute ago, 16. Subtract 1, so 3x equals 15. Divide by 3, you get x equals 5. Okay, I just don't try checking that. Yeah, always a good idea to check it. So if you do that, you go 3 times 5 is 15, plus 1 is 16. The 4th root of 16 is 2. 5 times 2 is 10. It does work. So always a good idea if it's an even root to check your answer. This one, you're going to square both sides. Right away, I'm thinking there's something funny here. Some of you might just stop and not even work this problem because you already know the answer, which would be pretty impressive. This is 9, so 2x equals 8. So x equals 4, and it looks pretty good, but let's just check it. 2 times 4 is 8, plus 1 is 9, square root of 9 is 3. 3 does not equal -3. That is not a real solution. There is no solution here. You could have stopped at the beginning because it says square root is equal to a negative, and that's just silliness there. That's not really true. Solve this one. So we're going to move the 3 over. So we get 2 times square root of x equals 4. Divide by 2, square root of x equals 2. Square both sides. Get x equals 4. Not a bad idea to check it. 2 times 2 minus 3 is 1. Move the 5 over the other side by subtracting it. So cube root of negative x, or x, equals -2. Put both sides to the 3rd power. That will get rid of the radical on the left-hand side. So you get x equals -8. And that's okay because the cube root to have a negative answer. That's no problem, actually. So this one, what I would think about doing is, and I'm expecting some extraneous solutions when we do this. Do not square it right now because you'd have to FOIL the left-hand side, would get really messy. I'm just going to move over that one. So by subtracting it, so I get square root of x plus 2 equals negative square root of x. I'm going to square both sides. And so we get x plus 2 equals x. Subtract x, I get 2 equals 0, which is not true. There is no solution. So that actually didn't surprise me. Just the way that problem was playing out with squaring a negative, I was thinking it might not work anyway. It might have been extraneous. 4x to the 3 halves, add 5, so that'd be 108. Hopefully I can do that. Divide by 4, so x to the 3 halves. Divided by 4 is like divided by 2 twice, so that'd be 54/27, I think. Okay, so now we're going to put this to the reciprocal power. So this is going to go to the 2/3 power, So this is x equals, I would write the prime factorization of that number because it's not prime. So there'll be 3 to the 3rd to the 2/3. So that's 6/3, which is 2. So it's really 3 squared, which is 9. And not a bad idea to check that. 9 to the 3 halves, the square root of 9 is 3. 3 cubed is 27. 27 times 4 is 108, minus 5 is 103. It does actually work there. So find these two, do the inside part first. So f of g of 4. So g of 4 would be, we're plugging in 4 right there. So it'd be square root of 4 is 2. 2 minus 1 is 1. F of 1, so we're plugging a 1 in right there. So that would be 2 times 1 is 2. Plus 1 is 3. And this one, g of f of x. So f of x, I'm plugging in all of that right here. So 2x plus 1 is my new x. I'm plugging that in everywhere there's an x. So I'm plugging this guy in right there. So this is going to be square root of 2x plus 1 minus 1, which actually is the answer. It doesn't really simplify any more than that. So first determine if it passes both tests. So let's just kind of graph this. Let's plug in a few points here. So 0, if we plug in 0, if we make a table here, I'm talking about like just kind of informally doing this. Plug in 0, you get 0 for x, negative x, 0 cubed. Plug in 1, you get, weird, you get negative 1, okay. Plug in 2, you get negative 8. Oof. Get 2, negative 8. Looks like I'm off the screen there. Oops. 2, negative 8. If I plug in negative 1, I get negative 1, which is positive 1. If I plug in negative 2, I get negative 8, which is positive 8. Negative 2, 8. And that's look like it's. So the graph of this has this kind of look to it. Something roughly like that. Okay, so does it pass the vertical line test? Yes, it only crosses at one point at a time. Does it pass the horizontal line test? Yes, so it does have an inverse. So if you take those 5 points we have and reflect them across this line, so there's like a dotted line called the identity line. You might want to write that down. It's good to know the name. At y equals x. So the equation of that line is y equals x, called the identity line. And we're going to take those 5 points we graphed and we're going to reflect them. So all the x's will become y's, y's will become x's. So instead of negative 1, 1, it's going to be 1, negative 1. Oh, weird. That's right here. Instead of 1, negative 1, it's going to be negative 1, 1. That's right here. So negative 2, 8, it's going to be, oh, wait. Let me double check this. Okay, so I'm going to have to write it out. So the ordered pair of the first one here, it was negative 1, 1. And now it's going to switch, right? So it's going to be 1, negative 1, which is there. Okay, so those 3 points, this point, and this point are the same for the inverse function. But this point is different. So if you look at, it helps me to write it out, negative 2, 8. The new point will be 8, negative 2. So that is different. The other point was, way down there was 2, negative 8. Now it would be negative 8, positive 2. So the graph of this one has this kind of a look to it. Roughly like that. And so that's the inverse of that function. So it's a pretty tough one to do, actually, pretty challenging. Let's look at this one. So absolute value of x plus 1, if you graph that, if you know the absolute value of x, we've graphed that earlier this year, you should move every point up. So move up 0, 0 instead of 1, 1, it's going to move up 1. So 2, 2, it's moved up 1. Just plot a few points there. If you know your parent graph, this is not too bad. So this graph has this kind of a look to it. Oops, something like that. And so then you're trying to figure out, does this function have an inverse? Well, does it pass the vertical line test? Yes, it's a function. Is it a one-to-one function? Does it pass the horizontal line test? No. So there is no inverse. Because if you draw a horizontal line, it crosses it more than one time. So you don't even have to find the inverse. There is no inverse to that one. Determine whether this function has an inverse. It looks linear. I think it's going to have an inverse here. So y equals mx plus b, it has an inverse. So let's find the inverse. So the step is, well, it's already y, so I'm going to switch x's and y's. X equals 5 minus 2y. Solve for y, so x minus 5 equals negative 2y divided by negative 2. We technically don't like a negative in the denominator, so I'm going to write it this way. Negative x plus 5, I'm changing the numerator, divided by positive 2 equals y. But the last step, I really like that y in the beginning, and we got to call it by its proper name. If this was a function, let's call it the f function. This would be f, the inverse of x equals negative x plus 5 over 2, something like that. This one is shaped like this. It's almost like a quadratic. It's an even function, so the end behavior is up and up, which means it doesn't pass the horizontal line test. There is no inverse. So if you just think about end behavior, you can see that doesn't have an inverse. It's not a one-to-one function. Graph each function. If you know the parent graph for this one, you know 0, 0, 1, 1, 4, 2 are the 3 points. We're multiplying those 3 points by 3. So let me just write those out. 0, 0, 1, 1, 4, 2. So if I multiply the y values by 3, that's going to be 0, 3, and 6. So 0, 0 is a point on my new graph. 1, 3 is a point on my new graph. And 4, 6 is a point on my new graph. Looks something like this. It goes up and to the right. This one, plot your parent graph to start with. We're going to do this in 2 steps. So this is a reflection over the x-axis. Let's do that. So my new points are here, here, and here. It's kind of going down right now, something like that. I'm just dotted line because it's not finished. And this one's moving it to the left 2 units. So every point moves left 2. That point is now there. That point is there. And that point is there. And my graph looks like this. So by graphing in your TI Inspire. Okay, so let's see. This first one, I'll do the method most people like better, which is subtract. So you set it equals 0 first. So 2x plus 5 minus 7 equals 0. And just graph up the left-hand side or whatever side has x on it. So this would be square root of 2x plus 5, I think that says. Minus 7. So don't graph the equals 0. That won't work out for you. And it looks like that. And we're trying to trace until we find the 0. So menu 5, 1. Looks like it's going to cross the x-axis, which is where the 0 is, somewhere way up there to the right. I think I passed it there. If you look at the bottom of the screen there, 22, 0. So x equals 22 would be my answer. You want the x value of that 0. Oops. And the next one, I'm just going to show you the other way. You could subtract square root of x here and graph it and trace. I'm going to just graph both sides. So I'm going to use the other method on this one. So left-hand side is square root of x. Hit tab to up entry line again. And the right-hand side is 3 minus x. And you're trying to find out where those two things cross. So you get menu, geometry, points and lines, intersection points. Click on both graphs. And you get an answer there of, it looks like 1.7. So x equals 1.7. We're not looking for the y value in either case. We're just looking for the x values. We're trying to solve for x. I think that is the last problem. It is. So that's it for today. For the review, hopefully you're ready for your test. Ask questions in class or by email for me, and I'll help you out.